Alright, time for another DraftPhysics.com video presentation. Alright, debatephysics.com also, but hard to get any reasonable debate, and there's some here, so I'll read some comments, but first I want to do some physics, yeah. I was thinking, I make the accusation that physics is a religion, and I guess you could kind of compare it to the Torah. It's supposed to be an evolving book, but it doesn't really evolve in the sense that they'll accept a new truth that you have to be clean, and they'll add use a detergent soap, but they won't get to the real point, which is there's a bunch of little bacteria that God never told us about that will attack your bodies, and some of them are very dangerous, and so you have to clean them all off because there's might be some of those really dangerous ones around. Some sort of truth. Just get to the truth. And instead, it just has to stay God-centered, and it has to be a fable and blah blah blah, instead of just a scientific book. A book of good advice. How to live a decent life. That's the simple book it should be, and instead it's not. And physics is doing the same thing in the sense that they're just so glued to a way of thinking, and they just won't be bent from it, so they have to change everything into just, instead of telling the truth, to getting it accurate, they have to sort of rebuild the fable and just add some new ingredients now and then. So anyway, in that vein, I sort of wanted to talk about, there was a time when they realized, that, you could create this vacuum thing. They put the two halves of a sphere together and pump the air out, okay? And it became impossible to pull it apart with horses. And the idea was, what do you think's happening? Is the vacuum a pulling force? Or is there something you don't really realize going on, which is there's absolutely tons of weight pushing on the spheres and pushing them together. And you don't see that weight, okay, if it's on both sides. So if you can create a place where there is no weight, it's a very powerful amount of pressure being applied because of the atmosphere. And so they got the right answer. But they never stuck with this idea that there's pushing forces in the universe. They still wanted to do this pulling thing. Somehow this is about pulling things together rather than pushing things together. So in the rest of the description of reality, instead of understanding gravity as a pushing force, that you're getting pushed into the earth, instead they turned it into this silly pulling thing, okay, where the imaginary pull thing is pulling, and it's somehow pulling on you, even though you can figure out that all the pulls are basically pushes in our life. You push on a rope, you don't pull on it. You push on the back of a doorknob, you don't pull on the doorknob. All that kind of stuff. And so you could take that the step further, where they never even bothered with this simple experiment. These are just so basic. This is like Archimedes kind of physics, and they just couldn't be bothered, and that should bother you people. It should bother anybody who is likes this whole science thing of trying to add up all the pieces, find this maze and see what the maze is really doing and what the puzzle is, solve the puzzle. It's a detective story, however you want to view it. You want to be Columbo, or you want to be the maze man, or you want to be the wizard who solves the little code and the door opens. However you want to look at it, it should intrigue you that the objective is to find the truth, not just some barely fitting fable. Anyway, so yeah, this basic experiment, I put something on a scale. Doesn't matter what I put on there, an elephant or a mouse. The scale will move, okay, and then I could take that scale, just put a little lever on there, hold it in that position, and then I could just turn it sideways, okay. And so now I have a certain spring compression, okay, that was created by gravity with the object there, whether it's the elephant or the mouse, it doesn't matter what it is. And now we're going to release the energy that gravity put in there, And the fact is that all these things, no matter what I put in here, will do the same thing they do in gravity. That is, they're going to move at the same speed. No matter what they are, they're going to fly out at the same exact speed. So whether it's a mouse or an elephant, I'm going to make them go the same speed. And it's going to be 1 mile per hour is my argument. Okay, that's what you've stored in the spring with the gravitational pressure, is just that. All right, and so if I did do the replacement, let's say I had two objects, I had a 2 mass and I had a 1 mass, and I take the 2 mass and compress the scale with the 2 mass, and then I turn it sideways and I lock the scale, and then I put the 1 mass in there to fool it, you know. What pressure do I have? I have the 2 masses pressure, okay, and now I'm going to replace it and put a 1 mass there. What's going to happen? Well, it's a 1 mass. It's half of what this is, and as Newton pointed out, okay, momentum is force, and the fact is what you're going to get is one velocity. If it was a 2 mass and you replaced it with a 1 mass, you're going to get twice the velocity. That's the only way to make the thing even. So you're going to get 2 miles per hour. All right, it's that simple. You know, these are so simple, these experiments, this observation. It's so easy to prove, and yet physics hasn't done it at all. They haven't even talked about. I've never seen a single reference anywhere in physics where they just talk about this simple idea that you just collect your gravitational pressure, turn the scale sideways, and see how much pressure you get back. It's the simplest way possible to measure how much energy is stored from the gravity. And whether it's a real velocity, and what it is, it's a real velocity. They keep talking about the acceleration part, but the fact is it all adds up to a velocity per an amount of time. I mean, Newton said 9.8 meters per, okay, 1 second, okay, not second squared, there's no second squared, it's just 9.8 per 1 meter, per 1 second of time in the gravity. And that's exactly how it comes out, and that's exactly how you concede the truth to be. So why are you pretending it has something to do with squared seconds when it just doesn't have anything to do with squared seconds? All right, and the other thing I wanted to talk about is just so, I think just such an obvious solution to a query is the magnet thing, right? Magnets are, this mysterious, look how mysterious it is. And they never thought, okay, it never occurred to them when their lodestone, was doing its magnetic thing, to just think about, well, what if it's an outside force? Okay, simple. There's an outside force that's hitting every object. And what happens with the magnet is that it converts that outside force into something different, okay? That the same force hits all these places, and out of this side, the force reflects a little differently than what it reflects on this side. This side does dotted line, okay, reflections, and this side, does squiggly line reflections. Simple solution to the problem of where does the energy come from. This thing looks like it's doing something, like it's a radioactive. That's how it looks. That's how it seems, like it's producing the magnetism. When no, all it's doing is changing how it reflects the universe that's hitting it all the time. And it's just saying, I'm going to reflect it a little differently. So it's going to look different. And that's what every object is doing. Every object in space is radiating a bunch of energy. The energy is not coming most of the time from inside of them. Obviously we have body heat that's created by us, but most of the energy is actually the atmospheric pressure, and we're pushing back. The gravity, we're pushing back. The ground pushes us. We push the atmosphere. And all of this other radiation coming from space that hits us, and we producing something different coming back out. It's just the simple truth. And this whole view, where everything, they have to think of everything as these emitters, and then the biggest reason why I guess they can't see any of this anymore, they can't even have the possibility of recognizing that everything is just reflecting the universe, absorbing it for a millisecond or two, and then it flies back out. Everything's at an equilibrium with the universe. And they're basically just taking stuff in and throwing it back out again. In the case of gravity, they're using it up by, melting the center of, keeping the center of the Earth melted. And so it's delaying how the energy goes in. It takes a while for the energy to come back out again, and that's gravity, that differential. And some simple answer. Instead, they turn this into a bent geodesic, some magical gravity pull force for which there's no explanation of where the energy comes from, nothing. And so because they've stolen that big piece of power in the universe, this gravitational force, and turned it into a nothing, they just don't see that, yes, it's as simple as the vacuum argument. The vacuum has no power. It's the fact that the vacuum's producing nothing to resist. That's why it looks that way. It's because the universe is full of energy. And the fact is, if you can push it out of the way, all right, you will create more pressure. And you're going to be stuck, having to do work to push it away, to be in an absolute real vacuum, a force vacuum anyway. It's impossible. And the material vacuum just means that the closer you are to something else that reflects, obviously means you're going to get more reflections. And if the stuff is moving towards you, you're going to get even more reflections because it's moving towards you. It's pushing towards you. Okay. Anyway, I can get into the whole, it's not the speed of light, it's the speed of force. I mean, this isn't a big, giant leap, right? This isn't stealing that much from them to say, maybe we should just retitle it. It's not the speed of light, it's the speed of force. That's a more accurate statement, that all this stuff moves at this speed. It's not just light. All the invisible geodesics, all the magical magnetism, all of this stuff moves the speed of light, because it's really just the speed of the force that fills the universe. All right. Yeah, okay. That's enough. Just a lament on, all of this should be reasonable conversation to have about, let's update our book of reality and get something, get somewhere near the truth. What's the more plausible explanation? That the magnet has some magical properties where it doesn't need to burn any fuel, but it produces radiation? Or is the more sensible answer that, no, the magnet just completely changes the way it looks, and by changing how it looks, it reflects the light in a pattern that's different, and things that also have that capacity to have a pattern can see the pattern. They can match the patterns. Not that complicated, really. And the patterns really are about charge, and I could explain again, it's two kinds of matter, two kinds of force, two kinds of interactions. The whole thing is explained. But they won't even listen to those arguments with any sincerity, and they will just cling to this. We've already written this Bible, and we're not going to rewrite it. And that's really all it's about. It's just they don't want to revise their theory. They don't want to change any of the words of their holy book and imply that their God is fallible and he screwed up and didn't give you the real story. All these religions sort of have that problem. I'd say, how much sincerity can you have in believing in your God and believing that he loves you or cares about you, and he wouldn't explain even the simplest things like the plague is being caused not by voodoo, it's not being a curse, it's not this, it's not that, it's the little fleas on the rats. He wouldn't even tell that it's the bacteria in the flea. He wouldn't even tell you that. He wouldn't even tell you, these simple little things. So anyway, just very poor behavior. So I guess we'll talk a little bit about the poor behavior, since this Barnes guy has written a couple of statements regarding his observations in arriving in this conversation. So that's sort of interesting. So I might as well read some of that, and we'll go through some other comments as well. So leave us do that. Should be able to do that without too much trouble. Is that what I want? I guess that's what I want. I don't know. I didn't need properties, thank you. I just want you to show the freaking image. There it is. Okay. Make it a little bigger. Not that you need to read along, really, but what the hell. All right. Jeez. Despite grievings and frustrations, I've had a fascinating discussion with this Alexander Zaptia individual. You should see the amount of senseless vitriol he has received just for inquiring into a basic question. It is unbelievable. Yeah, it's surprising, frankly. Okay, I mean, I didn't think this project would drag on for years. I figured that reasonable people would say, hey, you know what, that alternative idea does work. Even if people just stopped where Feynman left off. Feynman basically drew out mock gravity, pointed out how it perfectly works, it perfectly solves the gravitational problem. And because he doesn't have an answer to the drag point, he just says it doesn't work, it's no good. So there can't be a possible answer to the one flaw it has. No, instead we'll just throw it out and go with bent space instead. I just, even on its face, you're just saying, that doesn't seem very scientific. He's just basically saying, because I can't figure out the catch, therefore I'm really smart. I can't figure out the catch. You're never going to figure out the catch. Nobody can ever figure out the catch because I didn't do it. So therefore it must be a garbage idea. I mean, it's not, that's not very good science. But you can see in the history of science, frankly, it took thousands of years for somebody figured out an easier way to do something, and it would take 1,000 years for the rest of the world to catch on. 1,000 years. It's sad and tragic and pathetic. Even figuring out how to defeat the suit of armor with the longbow. You're saying, why would that take so long? Why wouldn't the idea of a bigger, stronger arrow not occur to somebody? You have these knights wiping out, 100 to 1 ratios in terms of how many, maybe 1,000 to 1 ratio. And you can defeat them with one good arrow. And nobody figured out that's all you need is one good arrow. Surprising. All right, these people are psychopathic, which explains their aversion to ephilism. Well, whatever. Whatever the side issues are, I made this channel separate for the very purpose of keeping those subjects separate, because I don't think they should have anything to do with each other. But yes, you can say the realm of philosophy, like the realm of science, is distorted and perverted by the clock stoppers. The people who just say, I don't want anything to change. I have advantage in the world that exists. I want things to stay this way. I want my subsidies. I want my this. I want my that. I want my house to increase in value by 10% a year, even though it doesn't make any sense, even though it's unsustainable. I want it. Anyway, Alexander Zaptia is really an enlightened individual, so, that's your opinion, who can see the forest from the trees, and vice versa, if I may say so. Lots of people get lots of things, okay, so the funny thing in this argument is I can't get any of these people to concede anything. They won't even utter the words that they wish there was more evidence. They wish they had done the Eddington experiment from space. They can't even say those words. That's how rigidly belligerent they are in their dumbassery, is they won't even concede that this whole argument should be moot, because all of these experiments should have been done. Somebody should have taken the scale and tipped it sideways. Come on. All right. The way I would describe it is, it's like he's building a house while others are still trying to tie their shoes. So that's all kind of your opinion. That's fine. I've had, positive and negative experiences with Zaptia. It would be turning to find yourself in such a state, so I completely sympathize with your and Zaptia's justified frustrations. Well, it's not even that it's frustrations, it's just that you do have to, at some point, decide to defend yourself. And, frankly, sometimes the only defense for a lunatic is, a bullet in their head. What are you going to do? A rabid dog? There's not much you can do except commit some crime against it, in a sense, to get force meeting force. Cheap shot meets cheap shot. And it's not really my choice. I mean, it's not, I didn't create this channel where I would do all these descriptions of a theory or an idea on a board and then say, go ahead and counter argue them, and instead they just spit on them, And there's a point where you're just sick of the spit. You're just saying, fuck you. You'll make a real argument or fuck off. So it all gets hostile over time. And the lying, is so egregious, about what the actual history is, who did what to who, all of that crap. And it's just, they're so dishonest and they lie so casually. That it all ends up being quite hostile. There's no justification for their nonsense experiments. Now that I would disagree with. I mean, there's all kinds of justification for attempting to resolve these questions. And, the point is whether they're going to be humble enough to recognize that their experiments aren't exactly bulletproof. Okay, that their experiments are not the, what should be the definition of a turning point in evidence. That it's not the key evidence on the table. The one that should be sitting there saying, look here, we have the gun with his fingerprints on it. It's not this perfect piece of evidence. There's a question about, well, but the gun's registered to Officer Fuckhead over there. It seems likely that Officer Fuckhead dropped the gun, at the scene, and not that the guy who's being convicted is guilty. So, all this evidence has to stand to some scrutiny, and it has to be of some substantial integrity. So I've pleaded over and over that the real piece of evidence is show me it taking 100 times the fuel, 100 times the watts, all right, to get a motor from 10 revolutions a second to 100 revolutions a second. I mean 10. Yeah, 10 to 100. Show me that it takes 100 times. That it takes 100 times the gasoline to go from 10 miles an hour to 100 miles an hour. That would be the real convincing piece of evidence. Obviously, they're never going to be able to contrive that evidence. They're never going to be able to show you it taking 4 times the energy to go twice as fast, because it doesn't. All right, and that's the tragic part, where they won't concede even the basics. And they contrive this nonsense. You make this counter. They make this argument somehow. I could put one mass on a scale, right? I put it on the scale. This battery, I put that on the scale, and that produces 1 unit of force in the spring. And then I do exactly the same thing. I just put 2 of them. And I just add a second one to the scale, and now I have 4 times the energy. All I did was add one thing. I did the same exact motion, and I add another one, and all of a sudden this one's worth 3. So this produces 1 unit of force, and this one produces 3 units of force. I mean, that argument is so illogical and nonsensical, and yet they'll shove it in my face and say, there, we've proven it. I don't know who you prove it to. I mean, somebody who really, you've proved it to the victim's daughter or something, who wants revenge. You haven't proven it to somebody who could be an honest observer. All right, so it either produces free energy or it doesn't. That is the question to get to. And it does seem kind of, I think the argument can be made that, with all these clever people, if it was really possible to double the momentum of something, that momentum is real. Momentum does knock down bowling pins. You can sort of calculate it. You could run it in slow motion, and you could see the momentum go from the ball into the pins. We can do that. They don't do it, but I'm just saying we can do that. Okay, we can see how collisions work and how the transfer is the transfer of momentum. And to date, no one has been able to monetize such a fantastical proposal. Yeah, well, that's a catch, isn't there? I mean, it is a fact that just glares and says to you, whatever the truth is, there has to be a conservation law, okay? And the conservation law can't be exponential energy creation because we would take advantage of it. All right, so then he says the poor state of science education is downstream of poor scientific thought. So I think this is just the human dilemma. And again, if I was watching a couple of those connections, the old James Burke thing, and they're really good. Really well written. He really had a he really had a way of presenting. The whole reenactment things were all very good, frankly. And, but I mean, obviously you could just say I can do this story a whole bunch of different ways and find all kinds of different characters to say, was the tipping point, the turning point in how things got changed. But what you really see out of all this is that there's really simple ideas, and it literally takes hundreds, if not thousands of years for the simple idea, the improvement, to be migrated. I mean, you almost argue, like, how could there be resistance to Pasteur's arguments about bacteria and, infecting people? And, it took literally, decades for them to really do what the facts were telling them, which is, avoid bacteria infections. Yeah. It is amazing how the Reddit glued science people love to invoke Leibniz. Well, I wish I could see that. I wish they would invoke Leibniz. The only one I've seen that's done that is whatever it is, that math guy. He has a whole page, of Leibniz glorification on his website. Because, well, look, Leibniz did do some stuff. I mean, he played with binary math long before anybody else did. He made little calculating machines. He did some stuff. I mean, I would argue it was all plagiarized. I mean, but that's all part of science. Science, like Thomas Edison. I mean, yeah, you take other guys' ideas and you make them actually work instead of fail. So there's nothing wrong with that. And Leibniz was a little bit like that. But, they really won't claim that is the theory, okay, that's the man, okay, that he's the first one who stood up and said, let's do this mv squared thing. And it was opposed to Newton, directly in opposition to. It's not an indirect attack. He was directly attacking. This guy actually wrote to kings and queens and princesses and dukes and earls and all those kind of people, trying to get them to censor Newton. He thought Newton was speaking heresy. Okay, so I mean, his attack was really aggressive. Popular and Young, and the Young experiment. Look, Young was a brilliant doctor. Did lots of stuff for color blindness. This, lots of really great science. But yeah, it was really trivial what he did with the slit experiments. It was, besides the fact that he didn't do anything original, in the sense this is all stuff Newton had already discovered, and he just came up with the, well, look, it's a wave statement, and there was no Newton around to say, well, no, the vector theory works just fine, you don't need any waves. Okay, as if they were some gods. Well, in some respects, frankly, they should be revered as humans who made great contribution to human understanding and progress. But what they shouldn't be is infallible. They shouldn't be thought of as, well, everything they said they meant. I mean, Faraday had some wacky ideas, and he conceded they were wacky. I mean, that he, that didn't work. But, he had this whole idea that, atoms were gears, and, there was all these gears inside of something, and the gears were moving the force around, and, doesn't work. Okay. What is one of his most brilliant observations? but it doesn't take away from the fact that all the other crap that he did discover. All right, so anyway, what is strange is how so many of your declared enemies, so they admit to bias, admit they don't understand any of the physics. Well, they admit that they, haven't done any of the research. Well, they sort of admit it. They won't overtly say, they just couldn't be bothered to actually look up Leibniz and what he believed in, solitons and monads and all the other kind of bullshit. So yeah, they take no responsibility for all the crap that comes with that. Like, why did Leibniz believe what he believed? And the reasons aren't very good. Okay, why should they be trusted, and why are they defending that which they don't understand? Well, that's the real question you got to ask, is the motivation of the people. And yes, clearly the motivation has more to do with resentments against me personally. So they don't like me. They want me to fail. They just have some, visceral reaction that compels them to be a hater. And okay, the fact that their tactics are so lowbrow and cheap is the part that, cast aspersion on their, they blow themselves up with their own bomb. They're hoist on their own cheap tactics in terms of their own credibility is lost. They're huge exaggerations. I mean, they can't even moderate how they describe their videos. And they keep calling everything they do a proof, and it's just such nonsense. All right, that I think is the best smoking gun evidence we have to conclude that they don't do this out of truth seeking. So this is the real problem. Science isn't truth seeking. Science is storytelling, and they're just looking for a fun story, a warp drive, Star Trekian, Star Warian future for themselves or something. I don't know. I don't know what their incentive is. It's all, to me, quite bleak to even imagine, fucktards in space. I just, the fucktards can't handle not dumping their sewage in the places where they go swimming. Why, why would I trust them in space? I mean, fuck. Too silly. They keep rebuilding their beach houses, I mean, these are really dumb people. I want them in space? No, I don't think I do. But just some sort of religious bias. Well, that's, science, as I'm stating, is pretty much just an establishment of pompous people wearing silly hats and $10,000 booties and walking around like, well, we have the secret code, we speak Latin, we're playing their little, we know what the little forky symbol means, the special forky symbol. So it's all about just, style points of some kind, pretending they're doing something smart when, yes, it's circular chess or something. I don't know. It doesn't go anywhere. People tend to be conformists. People tend to be ignorant, okay, because becoming unignorant isn't any fun. So people like to have fun. They don't like to do things that are work, and it's work to think outside of the conformity box, the 2+2 crap. Even if the evidence is handed to them that the mainstream is wrong. Well, even if the evidence is glaring, okay, that the mainstream hasn't really done its job, okay? When you don't repeat the Eddington experiment from space, you're not doing your job, because you don't need an eclipse, and it only takes 5 minutes, and there's 400 times better resolution from space. So, yeah, that's something you should get done. Shouldn't be a problem. I mean, sitting there in your, your simulated anti-gravity, and you could just throw 2 balls at each other and have them hit each other and watch what happens. And they can't even manage that. All right, so I pointed out that, yes, in the 1 dispar video I was wrong. It's a 1-to-3 mass ratio, so 50% of the velocity is way out of line. Shouldn't be going half as fast, and so, but anyway, the point is we've been over and over the 1-to-3 mass ratio. We're waiting on physicist Michael. He's supposed to do the experiment with a big Newton's cradle and, really get us some great data. But apparently he's having trouble acquiring the great data so far, so we don't have that evidence yet. It's certainly there's. I have to, I think it has to be conceded that these are two separate arguments. The mv squared thing is one argument, okay, to be disputed, whether that's what's conserved in the universe. Because it's certainly all the space arguments, the 10-ton train, 5-ton train arguments. Okay, they're never going to show you the 5-ton train having twice the energy. They're never going to collect twice the energy from the 5-ton train going twice as fast. It's not going to do anything to anything on Earth to demonstrate that it has twice the energy. So that's never going to happen. But this idea that in these translational collision experiments that there's this possibility that you can actually get twice the energy into something, like I throw the rubber ball at the building and the building absorbs the energy and I get a complete reflection. I'm not saying it's possible. I'm just saying that's sort of a separate subject. The fact that some experiments might look that way because we're not understanding what's really happening. The fact that you can't make the ideal lever and that every lever experiment you do, you have to calculate into it the fact that you don't have an ideal lever. The law of the lever doesn't work as a practical fact unless you modify it to the circumstance where it's going to be less than ideal. You have to always account for the less than idealness. All right, so the bullet in the ballistic pendulum. So this guy called Raphael Hofladay. Interesting, the old Hofladay name comes up. Anyway, I don't know anything about who Hofladay was, but whatever. Probably a religious kook, right? I imagine that's an old Greek thing or something. The bullet versus the ballistic pendulum is an inelastic collision. That is a different circumstance for which the state of momentum is conserved but kinetic energy is lost. Yeah, so I pointed that out in my last video, so I'd already responded to this. All right. And in the sense that, I've already talked about it in previous videos, but I certainly just did it before I read his comment. I did make those points. I did those clarifications. So this isn't about elastic and inelastic being the stumbling point. The stumbling point is, can you create free energy? All right. Elastic collisions, such as one demonstrated here, tend to produce a bounce which may create more, I guess it's absolute momentum, but which adds up to the original one if you subtract. Yeah, we already know this subtraction of the negatives, but I'm just saying, what's the sense in talking about such things? Because that's not how collisions work. Collisions are about something goes in and stuff comes out. There's one thing moving. There's one thing providing the energy. You're saying you can have an interaction where more energy comes out of that system. I mean, it's all thinking about it in space or something, and it just don't add up, unless you're saying you're converting the matter into energy somehow, or you have something radioactive in the experiment or something explosive in the experiment. How can you have more momentum out than you have momentum going in to a car crash? That's the simple argument. Let's see. Newton said as much in his Corollary 3. So we already did do this. So he says at the end, well, why didn't you, hasn't somebody already? Yes, I had this conversation with physicist Michael. Okay, he brought up this corollary. And the fact is I'm not going to read it just because it reads so poorly. And the real argument is could you please draw this corollary? Could you draw what Newton is saying here? Because I can't follow along. I mean, it's right line with this. Is he talking about a velocity or is he talking about motion? See, when he says the word motion, that you think is velocity, right? So are these velocities or are these momentums? I mean, it gets quite confusing because he doesn't use the word momentum. So I'm just saying, go ahead. If you can draw this, then maybe I can see it and I can understand what you're saying Newton said. But I'm still going to go back to Newton's more direct phrase, okay? Not in the corollary, but in the sentence right under his second law statement, he clearly says, you know, one amount of force, one amount of velocity, two amounts of force, two amounts of velocity, three amounts of force, three. He goes all the way to three, all right? So he's making the point quite clear. It's a one-to-one relationship between the force you put in and the momentum change you get out. One to one. Okay? Not squared, not any of that crap. So you can't, you know, again, you want to sit there and say, okay, Newton contradicted himself? Fine. But what was Newton arguing for the rest of his life? What did they argue from the point where, you know, in 1668, 1668, when Leibniz proposed this crap, you know, a year before Newton published, by the way, Leibniz published his mv squared theory, just to be an asshole. I mean, I would argue it's clear he was just being an asshole, right? Everybody knew Newton had spent 7 years in isolation writing the Principia, right? So he's been in isolation for whatever 5 to 7 years, working on this. So everybody knew this big giant thing was coming out of Newton. And, you know, just to play a game, Leibniz published his thesis, you know, the year before. Anyway, I mean, obviously gamesmanship is a reasonable accusation. Okay, and so he says, has nobody raised this with you? Well, yes, it has been raised. And I'm still going to counter-argue, okay, you're saying I have to deal with your quote. I'm saying you have to deal with my quote. All right? So it's clear, Newton's saying there's a one-to-one proportional relationship. It's clear that his math, when he actually writes it down, okay, I mean, it's force equals change in momentum over the change in time. It's clear. All he's saying is, you know, you can measure this force per second, or you could measure the force as a net force. So I could say force net, and then there'd be time total. And that's all that would matter. So it'd be 1 unit of time. Okay, so 1 into any number is going to be the same number. So it's really, he's saying there's a pure equivalency between force and the change in your momentum. And there is no, there's nothing in the way of that clear connection. All right, so anyway. Yeah, so that's the first reply. Okay, so I replied to that. I don't know how productive it is to argue direct quotes. I would argue the quote more relevant as to the subject is where he directly states 1 unit of force creates 1 unit of motion, blah, blah, blah. His formula pretty much stated that force simply equals the change in your momentum. Newton's surrogates argued against Leibniz right up to his death. Okay, so I'm just pointing out these are the facts. So why do you keep trying to put this garbage theory in Newton's mouth? It's not Newton's mechanics. And it's just so dishonest that they keep trying to make it Newton's mechanics. It's not Newton's mechanics. It's not Newton's theory. Newton didn't believe that, 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. He didn't believe that. Okay. I just published a video before reading this comment where I deal with elastic versus inelastic. So then I asked the question, do you really think if we could build a spring that could tolerate the velocity of a bullet, that the kinetic energy would be conserved in the ballistic pendulum? So it'd be nice if he answered my question. I mean, if there was some way to turn the bullet hitting the big giant heavy thing into an elastic, like if we could make it rubber, if we could put something in there to, even if we used a lower velocity bullet, frankly, isn't there some way we can make it so it elastically bounces off the surface, and then we could see if the ballistic pendulum retains its kinetic energy now, because it's an elastic collision, so therefore we're supposed to keep all of our all of the kinetic energy. I don't think the ballistic pendulum is going to move more because you bounce the bullet off of it. Okay, the argument's going to be that having the bullet penetrate the clay and stick inside of the object is more likely to absorb energy than having the bullet bounce off. Bouncing off isn't going to put the energy into the ballistic pendulum. I mean, but even that whole argument, I mean, I understand this is a basic argument, right? I mean, that's, you know, this is one of those things where you say, well, come on, can't any of these people, you know, Ian Gosling, any of these people, can't they just concede that, oh, okay, yeah, this one does fall a little short? You know, I got to think on this one, or yeah, that doesn't make too much sense. I mean, this whole idea that you have a brick wall and you're saying if you want to get the most energy possible into the wall, okay, tie it down to the ground, make it totally immovable, throw your ball and get 100% of your velocity back. Okay, so get 100% of your velocity back and you've gotten 200% of the energy into the wall. Okay. And the more the wall yields, so that is if I put the wall on wheels and I allow it to actually absorb momentum, that is it now moves, and I get less bounce back, okay, I'm only getting, whatever, 85%, okay. So when I get 85% back, I get less energy into the wall, okay, so now this is only 50 increase. And the more I get back, the less goes into the wall. And the less I get back, the more goes into the wall. I mean, the more I get back, the more goes into the wall. The less I get back. So when I make the ball absolutely stop, it's when I've put the least energy into the wall. I've only put in 100%, right? So when it doesn't bounce, I put in 100%. So when it moves freely, and the ball doesn't bounce, it just falls, because this moved really freely, so it's stuck essentially without glue though, because this moves so freely. Then I get 100% of the momentum into the wall. But if I want to get more than 100%, all I need to do is bounce it off. So the more it bounces back, somehow the more. So like I said, their theory is that there's 300% momentum here. I start with 100 momentums, I have 200 in here, and I get 100 back here. And they think that's a viable theory? Come on. I mean, I shouldn't have to argue that that has a huge amount of incontinuity in it, and it just doesn't, on its face, make any sense at all. That they should have some broader explanation for how this is possible. That reflections mean I put twice the energy into the object. Hard to believe. Not a credible argument, frankly. All right, anyway. All right, so then he says, I responded to you in detail. Well, so what? I frankly, look, I make videos. Okay, you write comments. That's, okay, we're already, I'm not going to write treatises. Okay, so I'm not going to do that. I'm not going to sit there and, you know, post 3 or 4 paragraphs of quotes and then, you know, add my own commentary and all that. No, for one individual, no, I'm not going to do that in the comment section. So, sorry, that's just not going to happen. And I did respond to your comment in the sense that, yes, I have already argued this. Okay, now I guess I could have pointed that out. But I'm not going to go look for the video response, you know, the whole conversation. I mean, I made my point. Okay, I mean, I have shown the text of Newton more than one, in, you know, 4 or 5 times in videos at least, the exact text. Okay, and there really shouldn't be. Frankly, I think it's just so dishonest of you to say there's really any evidence that Newton was a Leibnizian. He wasn't. It's not his theory. He didn't propose mv squared, and he didn't believe in mv squared, and Leibniz died completely discredited. There wasn't a scientist, not one scientist, who showed up at his funeral. They didn't even have money to bury him. And Newton was buried as a god. You got to understand that Newton won the argument in Newton's lifetime. Okay. But I see my comment only appears to myself. Well, I saw your comment. Kind of obviously, I responded to it, so I guess I must have seen it if I responded to it, right? I mean, I posted a response to it. Perhaps you did not get it. I don't understand. I responded to it. My response is right here. Your comment is right here. I responded to it. But I don't want to be mocking. All right. Perhaps you did not. Okay. Discourse is made impossible by these fractured communications. Yes, I would say Discord is impossible if you can't draw me pictures, frankly. Because what Newton writes in those 2 paragraphs, I can't follow it, all right? I'm not seeing it, okay? 15 units this way, there's 1 unit that way, 4 units this way, 6 units that... Yeah, sorry. As a word puzzle, I hate word problems, frankly. You know, there's 17 people on the train, and 6 of them have blue shoes, and 7 of them have red shoes, and 3 of them have no shoes, and then there's 6 people who are, you know, I mean, wearing their shoes on their head. I hate word problems. So maybe you want to argue word problems. I don't. All right, anyway. Let's see. Maybe went to your spam folder. So no, that really wasn't an issue. I like I said, I think I did respond to the basic points, and the point is, I pointed out I made a video. So there's another video you can comment on, okay, where I went over the elastic stuff, and I went over the ballistic pendulum stuff, and I went over all this stuff. All right. So let's see what the Barnes guy said to him. Google has an unfortunate culture in which they prioritize unnecessary, fruitless toy projects that are driven by hedonistic, capitalistic utility maximizations at cost of maintaining their own infrastructure. Well, I think the point is it's a popularity engine. It's not a search engine in the first place, and all it does is, it's lowest common denominator. I mean, it's the worst kind of scenario that we've created in terms of this library. There's 7 books, in the front of the library, and those are the books that the librarians just keep shoving in front of everybody, and the rest of the library is almost inaccessible. And there's certainly no card catalog. There's no way to go find anything. All right. End of the mushy rant. Yeah, that was a little bit, well, whatever. You're not really understanding graph science theory. All motion is in a form of force as supported by Newton. This is Newton's second law. Yeah, he didn't say F equals ma. And the so-called F equals ma perversion is a product of historical revisionism. Yes, so, and it's not even that Newton wouldn't say something like F equals ma. It's harmless. Mass times the acceleration. But Newton would have never thought the acceleration is squared. Okay, Newton wouldn't say that. Newton wouldn't say per second per second. Newton would have said the acceleration is just a change in velocity. It's just a way of, you have a velocity and you change it. You make it shorter, you make it more. You add a block, you subtract a block. There's no other function. The acceleration isn't some special kind of velocity. It's just a change in the velocity. All right. DraftScience builds on this by proposing that there is a particle mechanism behind all such force mechanisms. I don't care whether it's a particle, it's a discrete quanta of momentum. That momentum is everything. MV really does go all the way down to electrons and protons and the little bits that they're getting hit by all the time. The little quanta. All right. As Einstein put it, right, do you say quanta of energy? Energy quanta. Hence, F equals mv is the correct formula. Yes, it's always just about your velocity, but you can certainly recognize when there's a change in the velocity, there's going to be a force that causes the change. So it would be mv, the velocity of the acceleration. The net effect of the acceleration is a change in the velocity. So the net force is always a product of the net acceleration. All right. So there's some more by the Holiday guy. Let's see. It appears that the artifacts. Okay, so this is just has to do with that French video where I had it wrong about the masses anyway. No, this is the video before that where there's this weird artifact on the stream. So yeah, he concedes that yes, in the original video you can see the artifact. It isn't YouTube's fault. It actually is on his data. His computer data created it. And again, it doesn't prove one way or the other. It's just a symptom where you're saying what is causing that, because frankly it's suspicious. All right, so this Dundag thing, comment. I haven't read yet. So I came across your video on the electromagnetic spectrum because it was recommended by the YouTube algorithm. Yeah, sure it was. Anyway, you put considerable effort into analyzing. So I didn't put any effort into analyzing Neil deGrasse Tyson's explanation. I watched the video cold, okay, without pre-watching it. And you know, the simple truth is that I've been making these arguments for years, okay, years, decade, frankly, and I'm arguing with physics. I'm not arguing with Neil deGrasse Tyson. I'm arguing with physics, okay, the entire community of physics that keeps saying that this wave thing has been proven, okay, that there's nail in the coffin evidence, that this Young experiment is somehow profoundly revealing when it revealed nothing except how fallible human perception is, because you couldn't even tell he wasn't looking at a double slit pattern. He was looking at a single slit pattern. He created a single slit pattern using a double slit. Okay, not a great, brilliant thing to do. All right. You put considerable effort into analyzing Neil deGrasse's explanations in your reaction video. As a first-time viewer of your work, I sensed a strong critical tone throughout. Well, again, my strong critical tone has been earned because all I have gotten is harassments and attacks that go deep into my personal life by lunatics, okay, who say you're not allowed to even counter-argue their theory. You're not even allowed to bring the subject of evolution up. We are going to burn you at the stake. I mean, it's hysterically silly what these advocates, these science defenders will resort to, okay, you know, obvious that this is just a description of the nature of human garbage. And again, you're going to rationalize it and excuse it, apparently. You're some sort of tennis player, apparently. I felt as though this aim was more to highlight a difference in intellect rather than to argue with the content constructively. So I don't know how else you can, I mean, how more constructive you can be than to point out how, no, I counter-argued his theory that it has to be a wave by pointing out vectors work just fine. This has nothing to do, that there's experiments that already demonstrate the fact that it can't be interference in space because you can do the radar or radio experiment and the two waves never interact with each other. So how could they be interfering with each other if they never pass each other's path? If they never have an intersecting vector, right? I mean, the two slit is drawn this way, and oh, look, the waves intersect, and blah, 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 all this magic happens. But you can do the experiment this way. They never intersect, and they hit the antenna in the middle, and you get the same fringe pattern. So I'm just saying these deductions can be made, and they haven't bothered to even deduce them, let alone acknowledge that somebody else did deduce them, and that they should have a counter-argument for which they don't have. I felt as though the aim was more to highlight, anyway, which was a bit disheartening. So I just amazing that you're disheartened by the depth of my arguments, the fact that I will make videos over and over explaining in detail every possible way I can explain to you why I believe what I believe and why I believe what they state is nonsense, and they produce no frickin' counter argument whatsoever. Nothing. Absolutely no explanation, no argument countering a single thing I ever propose or argue. And amazing, you're disheartened by my reaction. Ugh. Sorry, you're pathetic. Okay, anyway. There's a lot of potential in what you're doing. So it's just, what does that even mean? You know, if you're saying it's not constructive, then I guess there's no potential in it. Anyway, and I believe your content could really shine with more balanced approach that respectfully challenges ideas. There's no way to respectfully challenge their ideas, okay? This is a lie. And you can see it. Look, I'll bring up the electric boom thing, right? Professor Lewin for decades has been arguing he proved that there's two voltages in the same location on a wire. Okay, that this is a real thing, okay, that somehow it's possible that there could be two different voltages in the same fucking location in space. An electric boom made a simple argument. I think you're misinterpreting. I mean, it's a induced field, okay? It's a field creating, okay, the voltage, right? It's an induced, you're using a coil to produce induction in a wires. And the reason why you're measuring two different voltages is because your probe wires are in the field. There's no way to evade the fact that they're going to distort your measurements, because there's no way you can undo the fact that your probe wires are going to be affected by that induction. You can't insulate them well enough. You can't do anything to prevent them from being part of the experiment. They changed the experiment by being in the experiment. A simple enough argument, and Professor Lewin called him a flat earther. All right, so I mean, there's nothing, there's no, this is just so bullshit for you to sit there and argue that I'm the one that lacks balance. No, these people cannot accept any critique of their physics. They can't accept any. You can't even say something like, well, why haven't they done the Eddington experiment from space? I mean, it's so rational a thing to do. 400 times better resolution. Why the hell wouldn't they do the experiment? I mean, it's nothing. It's a nothing experiment. Cost them $55 of satellite time. I mean, that's how much it would cost. It's $55 experiment, and NASA can't do it. It's pathetically silly. Of course, they've done it, and it didn't work. That respectfully challenges ideas without overshadowing the educational intent. I mean, what educational intent was there in deGrasse Tyson's mush video? I mean, I'm going to talk about photons and analogize it to potato chips. And, I mean, it was just so mushy and useless in terms of getting to the real point. And then the whole thing had an icon that said wave particle. And there was nothing in the video about the wave and particle. It was just about the fact that there's a spectrum. That radio waves and gamma rays are all the same thing. They're just in a slightly different form. So that's the content of the video. And he titled it something, his icon said he was going to talk about waves. He didn't talk about waves. He didn't talk about particles. So they lie about what their own content is. And that's my fault. Oh, I see. I mean, fuck you. All right, anyway. Okay, so then I did respond to this video by making a video. So, don't they claim that a single photon, electron, or even proton will interfere with itself in the double slit? And I've explained over and over. I went into detail about how those experiments are done, and they're never guaranteed to have a single photon in the sense of a single piece of energy in the experiment at the same time. We know it's energy that creates photons. All right, and it depends on how you apply the energy, how many photons you'll be able to create. All right. So enough said. And such. I think those are the only, I know this is somewhat off topic, so I did that too. Why removes but there's one thing I don't understand in model account. Oh yeah, hydrogen. I did the whole thing on hydrogen. I'm not a hydrogen expert. I've just pointed out that I think the fact that neutrons and hydrogen are almost inseparable in terms of their structure, is just sort of the giveaway. Is that this is again semantics. This is a word problem. The word hydrogen and the word neutron, what you're really just saying is, the elemental, what's the most elemental form of a dipole? And I guess I would just argue that obviously it's an association between a proton and an electron. That's, whether how close they are is really going to decide whether, this is a neutron, this is hydrogen. That's all you're really saying. I mean, that's all the material reality. That's the only distinction, is distance. How big is the dipole? All right, anyway, how much space does it occupy? Yeah. All right. So, till the next time, it's such. I'll call this a video. Such. So, thank you for the comments. It's good to get something. Some of them on point. perfectly respectable, blah, blah, blah. So that is constructive. The simple truth is, again, I would prefer that somebody could actually make counter arguments where they could include some sort of dynamic drawing, okay, because it's so much easier to follow along than somebody having to explain, well, then you lock the scale, and then you turn the scale sideways, and then, you know. It's, so, I'm just saying, reading Newton. I mean, Newton had a couple of drawings, but he used one. They had to maximize, minimize the number of drawings in books in the old days because somebody had to cut it, out of wood and all that kind of stuff. So he uses one drawing to illustrate 15 ideas. And there's A, B, C, D's, F, G's, 1, 2, 3, 7, 8, 9s. There's lines all over the place, and it's almost impossible to decipher, frankly. So, it's just, you have to, it's a modern age. We shouldn't have to be confined to the least amount of technology being applied to, providing the argument. And so maybe you could find a video that does that, that defends that Newton colory, in some way where it's illustrated. Because, frankly, without an illustration, it's, I find it uselessly convoluted. And it's this whole translation thing. I think it's just very unfortunate that scientists thought they had to write in the secret language, Latin, and they wouldn't just write in the popular language of English. Really annoying. All right, anyway, so till the next time and such and so forth and whatnot.